So up to 20th we have discussed in the previous session. Now we continue with the same exercise with question number 21. Let's see that. Limit x tends to 0. You have cosec x minus cot x. We don't have any formula for cosec and cot. So obviously, what's the first step? Yes, reduce into sine cos. So this is just 1 minus sine x upon cos x upon sine x. So what we are getting? Limit x tends to 0, 1 minus cos x upon sine x. So can you recall? In any limit question, if you have 1 minus cos or 1 plus cos, take the conjugate. Without that also it can be done, remember, but this is comparatively easier. So I'm taking conjugate of what? 1 minus cos. What's the conjugate? Same expression with opposite sign. So 1 plus cos x, 1 plus cos x. Multiply and dividing with this. Why we did this? You must be knowing, because this into this gives us what? 1 minus cos square, which is sine square. A minus b, a plus b. This sine x as it is, and the other part of the conjugate always remain as it is. So this one as it is. This part I've used with this 1 minus cos, 1 plus cos. What is that? 1 minus cos square. What is 1 minus cos square x? You know it is sine square x. So I wrote directly here. Now, obviously one sine will get cancelled here. So we are left with this. Limit x tends to 0, sine x upon 1 plus cos x. Now, here you have cosine, so you can apply the limit there directly. Here also you can apply the limit because this is 0. 1 plus cos 0. What I did, I have applied the limit. What is sine 0? 0. 1 plus what is cos 0? 1. So upon 2. So limit is 0. So 0 by 2 gives us 0. This is not undefined form, remember. Numerator expression can be 0. So this function is very close to 0 whenever x is very close to 0. Right? Now question number 22. Let's see that. Next question. In this 22, what is given to? This is also a good question. A limit x tends to pi by 2, tan 2x upon x minus pi by 2. Okay. So I need to set tan x upon x, remember. So same angle should be there in the numerator. Fine. Now there are number of ways to do this question. What you can do is, probably this is easier way for us. I cannot set this directly, for example, this angle. So I'll take this as some new variable. This is called substitution. I'll take this as some new variable, say y, anything. So denominator में y हो गया. Here I've this y. Whole question you are going to convert into y. Now x tends to pi by 2 है, तो यहाँ पे pi by 2 रखो. ये क्या हो गया? 0 हो गया. That means y tends to 0. It's obvious, if x is very close to pi by 2, तो दोनों का difference 0 ही होगा. तो y tends to 0. है समझ में? I repeat. I need to reduce this entire limit question now in form of which variable? Variable y. X is very close to which number? Pi by 2. तो यहाँ पे pi by 2 रखो. What is this? Pi by 2 minus pi by 2, 0. That means y is close to 0. Now here also I need to put the value of x. X, remember. So tan 2 as it is. What's the value of x? That's pi by 2 plus y. Pi by 2 plus y. What I did, I've just placed the value of x, which is pi by 2 plus y. So now entire question is in form of new limit, new variable y. So here upon y as it is, take 2 inside. So what we'll get here? If I take 2 inside, we'll get the pi plus 2y. I hope this is clear to you. Within the angle, you are taking 2 inside. So pi plus 2y. Okay. Now, trigo concept. Pi plus something. Which quadrant? third quadrant. Do you remember in third quadrant tan is positive or negative? In third quadrant tan is positive or negative? You know it is positive. So it is just tan 2y. All STC. Do you remember? All STC. In the third quadrant tan and quad both are positive. Pi plus, pi is here. Plus something means which quadrant? Third quadrant. Trigo function. Upon you have y. But I need same angle. So I'll write here into 2, here into 2. Remember. That you know now very well. Now what is this? See, this is standard formula. Tan x upon x, angle same ho gaya. So this has to be 1. This is a constant. So the final limit is 2. This is one way by substitution. Directly you can also try to set this if you want. Try yourselves. I feel this is easier for us. So I did this way. Okay. Now question number 23 onwards. We have here two different functions. In question number 23, see their function is this. 2x plus 3. When you use this, if x is less than or equal to 0. And 3 into x plus 1 when we use this if x is greater than 0. Right? Function has two different formulas. I repeat what this question says. If x ka value is 0 or less than 0 then use this. If x is more than 0 then use this 3 into x plus 1. Fine. Suppose if I want to find f of 1 so I should use this. मेरे को f of 1 फाइंड करना है तो 1 is more than 0 तो I should use this 3 into 1 plus 1 2 6. Suppose मेरे को f of minus 1 फाइंड करना है तो I should use this. So minus 2 plus 3 which is 1 that way. Understood what I'm trying to tell you? If x is negative or 0 use this formula. If x is positive use this formula. Okay. Now we are asked to find two limits. So we find these two limits. One is this. Limit x tends to 0 of fx. Now you see such things we were not having in earlier questions, but here x is 0 here, x is less than 0, that is this side, ek formula. X is more than 0 this side, दूसरी formula. That means you cannot directly evaluate this. आप fx की जगह पे कौन सा रखेंगे, ये रखेंगे, ये रखेंगे, that question arises. It means here you need to find these two limits. Limit x tends to 0 from left of the function and limit x tends to 0 from right of the function. Have you realized? This you have decided. Why? Based on the question. Because question में दो different functions हैं. So one should be used to evaluate LHS limit and the one should be used to evaluate RHS limit. I hope this is clear to you what I'm trying to tell you. If I do not evaluate this, for example, I'm not evaluating this. So how do you judge? यहाँ पे कौन सा function रखेंगे? ये रखेंगे, ये रखेंगे, obviously. So one has to get into two different limits. Now, हो गया. See, what's the meaning of this? You know very well. X is less than 0. X is from left side, this side of 0. If x is less than 0, then which formula should be used? Question में देखो, less than 0, then 2x plus 3 should be used. Up to this it is important. Then there is nothing. X tends to 0 from right. This side से आ. So x is more than 0 here. That's the meaning of limit from right and left, remember. Right? This does not mean that 0 is positive and here 0 is negative. Just it's a symbol, remember. There is nothing like positive and negative. X is more than 0, then which formula? This one, 3 into x plus 1. Now just apply the limit. आपको 0 minus को 0 ही रखना है यहाँ पे, remember, because it is close to 0, but from this side. So here 0 plus 3. So what will get? 3. What about this? Here 3 into 0 plus 1. So this is also 3. So what you have proved? Can you recall that result? Limit from left is 3, limit from right is also 3, and therefore you can say that the limit of the function, now not plus or minus, not right or left, remember, of the function. A function a भी हो सकता है और a भी हो सकता है, but limit is always 3, remember. Right? Why this? Because limit from right and the limit from right and the left both are equal. So as per that result, this limit has to be 3. I hope this is clear to you, right? Now same way, we find this limit. Which limit? Limit x tends to 1 here of fx. Now here you are asked to find limit tends to 1. Same question with different limit, remember. 1 is here, for example. 0 is here. Now if it is from left side close to 1 or right side close to 1. But it will be always more than 0. So here you will not be having left and right hand side limit. Only you will be having just this function. I repeat. See, that's important here. See, what I'm trying to tell you. You are finding limit x tends to 1. X tends to 1 means what? It's very close to 1. Now it may be close to left hand side as well as right hand side. But anyway it will be always greater than 0. 0 se to bada hi hoga. It will not be less than 0. This x will not be on the left hand side. If x is more than 0, then there is only one function. Which function? This one. So यहाँ पे directly आपको right left करने की जरूरत नहीं. Limit x tends to 1. Just place the limit 3 into x plus 1. This is clear? There is more to understand than to write. मैं वापस यहाँ पे लिखवाता हूँ. If x is close to 1, then x is always positive. Whether you can just have a look at this line, you will realize x is always more than 1. It will not be less than 0, remember. It will be always more than 0. It will not be less than 0. If it is not less than 0, then there is no question of use of this formula. You are going to use just this much. So that's how I have placed this. So here there is no concept of the right left limit in this question. Now you just apply the limit. So 3 into, this is very simple function. So you'll get the 6. 6 is the required limit here. In the first case the limit was 3. Now it is 6. Fine? Okay. Let's see next question. Question number 24. There again function has two different expressions. X squared minus 1 when if x is less than or equal to 1. Minus x squared minus 1 if x is more than 1. If x is less than or equal to 1, you are going to use this. If x is more than 1, you are going to use this. This is given to you, remember. What is asked in the question? We find this. This is the question. What's the question? Limit x tends to 1 of fx. So, you are taking the limit close to which number? 1. So, some values for left hand side x is less than 1. Here. X is less than 1. If I choose these values, x is more than 1. More than 1, less than 1. So, you have two different expressions. So, I need to evaluate what? LHS and RHS limit here. Limit x tends to 1 from left of fx. These, again I am emphasizing, does not mean 1 is negative. It means you are taking values from this side. So, here x is less than 1. Remember. Limit x tends to 1 from right. 1 ही रखना है. This is just a symbol. This means x is more than 1. And here fx. Why I have considered here two different limits? Because here function is about less than or equal to 1 and greater than 1. So this is equals to limit x tends to 1 from left. So x is less than 1. If x is less than 1, then which formula? X squared minus 1. This is for less than or equal to. This is limit x tends to 1 from right of fx. What is fx? X is more than 1 minus x square minus 1. Now apply the limit here. आपको 1 minus means minus 1 नहीं रखना है. Remember, रखना तो 1 ही है. Again I'm emphasizing, don't get confused that this is minus 1. This is not minus 1. This is 1 only. This indicates that here x is less than 1 and close to 1. You are going to put 1 only. 1 square minus 1. So this is 0. Put 1 here. Minus here 1 square minus 1. So minus 2. Can you recall that box question which we did? See, limits from here, limit from left is 0, limit from right is -2. So here, limit extends to 1 left of the function is not equals to limit extends to 1 from right of the function. And therefore, what's the conclusion? This limit, अब आपको प्लस माइनस लिखने की जरूरत नहीं है, limit of the function doesn't exist. You know, right? Which already explained by an example. Limit from left and the limit from right are different. Therefore, the limit of the function here does not exist. At where? At 1, remember. If you want, you can just write at 1. At 1, limit of the function doesn't exist. Right? You know that the limit of a function exists only when these two are equal, right and left, both the limits are equal. Otherwise, we say that the limit of the function doesn't exist. Okay. Next question. Let's see 25. Question number 25 here. All are basic questions, remember. What's the function there? You have modulus x upon x if x is not 0. And if x is 0, the value is 0. That's given to you. This is given, remember. This is given. What is given to us? If x is not 0, then you have this. If x is 0, then the value of the function is 0. This is given to you. Now we are asked to find this limit. Which limit here? Limit x tends to 0 of fx. Now tends to 0 here. So you may have values from this side as well as this side. If you take values from this side, then here x is less than 0. So negative. Here if I take from this side, x is more than 0. And you know that modulus depends upon negative and positive. So here, as per the given question, you need to split into two limits. Limit x tends to 0 from left of fx and limit x tends to 0 from right of the fx. Why? Because that's given number. X tends to 0 here, that's why. Or keep in your mind, this is very standard statement. If you have modulus function, then normally you should consider right and left limits. I repeat, if you have modulus function, then normally you should consider right and left limit. Okay. So now what is the meaning of this? X is less than 0. If x is less than 0, what's the modulus x? Recall function chapter. It is minus x. I think you know this. Recall function chapter, you will realize. So fx क्या हो जाएगा? Modulus x upon x. So minus x upon x. This will get cancelled. So limit is -1, constant. X will get cancelled, obviously. You cannot apply the limit because you will get the 0 by 0. Come to this now. Limit from right. What's the meaning of this limit from right? X is greater than 0. If x is greater than 0, what's the modulus x? It is x. You know, function chapter, types of functions. Go there, you will realize, right? So here, limit x tends to 0 from right. What is the function here? Modulus x upon x. But modulus x is x, in this case, upon x. This will get cancelled. Limit is 1 here. Constant. A1 हो गया ना, once they get cancelled. A minus -1 हो गया once they get cancelled. So limit from left is -1. Limit from right is 1. So what's the conclusion? I'll write here. The conclusion is this limit doesn't exist. Limit x tends to 0 of fx does not exist at 0. Does not exist at 0 because you are evaluating at 0. Fine? Understood. It's a really good question. It's a nice question. In 12th also we are going to use this. This is very fundamental, remember. May not be important for 11th final exam, but it is important for 12th. Keep in your mind. मॉड्यूलस है तो राइट लेफ्ट में मैंने स्प्लिट किया. x less than 0, modulus x is minus x, 11th standard. Chapter of relations and functions, you know. X greater than 0, modulus x is x. That is the only important part in this entire solution. Modulus x become minus x. So xx will goes away, minus 1. Xx will goes away, 1. Limit from left, minus 1. Limit from right, 1. And therefore, you can say that the limit of the function doesn't exist. Right. Now, based on this question number 25, I'll give you one more question for you. Based on this 25th, function is same. Based on this means what? The function is same. Find this limit. Limit x tends to 1 of fx. Right. Try this. Let's see whether you can do or not. x tends to 1 कर दिया. Function is same. आपको वही function लेना है. यही concept use करना है. You are going to use this only. Function ही use करना है. But what I did, instead of tends to 0, I wrote tends to 1. Right? Now, based on question number 24, one more I'll give you. That is, use the function from 24. And I'll ask you this. Limit x tends to, let me write here, minus 1 of fx. Try this. This is for you. Right? When you submit the homework, try to solve this. I'll check whether you can solve these two questions or not. This is based on question number 24. That means आपको ये concept use करना है. You are going to use this. And here, instead of, you were asked two questions, tends to 1, and what else you were asked? Achha, this was only asked. But now I changed the question. I wrote tends to 0. Let's see. Tends to minus 1, I'm sorry. One more I can ask based on 24. Use this and evaluate this limit. X tends to your 2 of fx. These are not difficult questions. If you think for a while, you can do it, I'm sure. Difficult nahi hai. Verbally you can answer, in fact. These three questions hardly takes 1 minute to do this, right? These two questions based on 24, this based on 25th. Try this. 26 I'll not do now. It's the same question. 26 is just same as question number 25. उसका copy है, खाली reciprocal है. Answer everything is same. वहाँ पे x upon minus x and x upon x हो जाएगा. So I'll not do that. You try yourselves. I'll go to 27 now. Question number 27. What about that? There the function is this. You are given modulus x minus 5. And what is asked? We are asked to find this limit. We find limit x tends to 5 of fx. This is really nice question. Once I do this, I suppose I'm sure you can answer 24th, this one and this one. Now, before few minutes, I already told you that when you have modulus, you should consider right and left. But that's not always true, remember. See here, you have x tends to 5. That is not the general statement. Normally, you should do it. A calculus ka limitation hai. Something that may not be generalized for every question. So, if I consider left limit, values of x are somewhere here. यहाँ पे 4 है. यहाँ पे 6 है. If I consider right limit, values of x are this side. But in both the cases, somewhere you have 0 here. In both the cases, x is always positive. If I take from this side or this side, x is always positive. वो 0 की right side ही है. So therefore, the modulus x will be just x, remember. If I change the question, if I write tends to 0, then you need to consider right and left limit, remember. But here not. Why? Because हम लोग कोई modulus remove करना है, तो we need to see whether inner number is positive or negative. But here inner number is always positive. Fine. Whether I take from this side or this side, what you can do? You can consider limit from right as well as limit from left. But from either side, the value of x will be always positive. So therefore, modulus x will be x only. So here, no need to consider right and left limit. You can just write limit x tends to 5, the same function. But modulus x will be x. So here x minus 5. I hope this is clear to you. And what about this? This is just 5 minus 5. So limit is 0. Clear? So sometimes you need to think the question and where the limit you are asked, that you need to see. Every time, even you would have done it by right and left, you would have the same answer. Suppose by mistake जल्दी जल्दी में आपने right left कर दिया तो भी गलत नहीं है. Because see, like this, what I'm trying to tell you. Suppose मैंने modulus दिखा और I told you do right and left. So x tends to 5 from right of fx. Here limit x tends to 5 from left of fx. Suppose जल्दी जल्दी में ही लिख दिया, ये सोचा नहीं. Then also doesn't make any difference. Your answer will be same. X tends to 5 from right side. So x is more than 5. X तो positive ही है, तो modulus x तो x ही रहेगा. So here limit x tends to 5 from right. Modulus x is x, so x minus 5. You know function chapter. This become x. Now apply limit, so ये 0 हो गया. Go to this side. X is here less than 5. Less than 5 means यहीं कहीं पे है. 0 के लेफ्ट साइड नहीं चला गया, तो मॉड्यूलस x तो x ही रहेगा, you know. So here also limit x tends to 5 from left, you have x minus 5. So this, you apply the limit 5 minus 5 again 0. So you see limit from left and limit from right, both are 5 and therefore the limit is 5. Therefore you can write this. It's not wrong. Suppose if you have started right and left limit, it's some extra work you did, but it was not necessary. See, this way also you could have done it. Fine, understood. But I hope you must have realized what I'm trying to tell you here and what here. Now in the same question, one more for you. Oh, so many questions I'm giving you. Here I'll just change. Function will be same, but मैं अब लिख दूँ यहाँ पे limit x tends to, this is for you, limit x tends to 0 कर दो. Now you need to think. Got it? Try. This is for you. What happens? See? You can answer all these questions. That means you have understood all the concepts so far. Tends to 0 कर दिया. Function तो यही choose करना है. अब देखो आप क्या हो रहा है. Okay. मैं और एक लिखूँ यहाँ पे. One more for you. Limit x tends to, I'll write here minus 1 I write. And fx. Try this. One more for you. See what you are getting. Fine. You must try all this, and if you are unable to do, you must tell me. I'll do it. I'll help you. But I'm sure after doing around 27 questions, you must have realized what is going on in the limits. Fine. Now, next question, 28. Question number 28. That's something different. There you are asked the values of a and b, unknowns. Your function is like this. A plus bx, where x is less than 1. X equals to 1 and b minus ax if x is more than 1. Right? What this definition says, if value of x is less than 1, use this function. If x is 1, that is f of 1 indirectly. What did this says? F of 1 is 4. This is given to you. You are not going to decide here. When x is 1, then the value of the function is 4. If x is more than 1, then the value of the function is b minus ax. And this is also given to you. What's given in the question? You are also given that limit x tends to 1 of fx is f of 1. f of 1 कितना है? 4 है. ये रहा f of 1, as I told you. If x is 1, the value of the function is 4. So indirectly this is given to you. Limit x tends to 1 of fx equals to 4. This is given. You are not going to find the limit. You are given the limit 4. Now you know you are given tends to 1. Fine. And limit मिल रहा है, that is 4. Now you recall one of the result. If limit is 4, that means right and left limit भी 4 होना चाहिए. So left hand side limit equals to right hand side limit of the function has to be 4. I've used the result. Can you recall the result? What that result says? If the limit exists, then the limit from left and the limit from right, both should be 4. In place of the single limit, I have placed the LHS and RHS limit. You know, this is very well known standard result, which we did in the first session. The single limit, I'll just remind you here, we did this. Limit extends to a from left equals to limit extends to a from right of fx. अगर ये दोनों same होगा तो that's the limit of function, you know. So what I did, in place of this, I placed these two limits. Fine. Okay. Now let's do this. Extends to 1 from left. Now ये question होगा कि क्यों सर आपने right left में split किया? Because here you have inequality in the function. Inequality in the function, and your limit based on less than 1 and more than 1. You see, limit is based on less than 1 and more than 1. So we need to x is less than 1 here. If x is less than 1, then this which formula? A plus bx equals to limit extends to 1 from right. X is more than 1. If x is more than 1, then which formula? B minus ax. And equals to 4 तो ऊपर से आ ही रहा है. ये आपने derive नहीं किया. This is given, remember. These two things you are given, this and this. Okay. Now we just apply limit because this is so simple function. So I'll write tends to 1. So a plus b into 1. Here also I'm going to apply the limit. You are not going to write minus 1 plus 1. I'm again emphasizing. So b minus a into 1 equals to 4. So you are getting two equations. A plus b equals to 4 and b minus a equals to again 4. What we do? We just solve these two equations. Solving these two equations, you know how to solve these two. We do by what? Elimination. So let's do by elimination. So we'll get the values of a and b. Just add them. So a will goes away. So 2b equals to 8. Just I'm adding this. So a will get cancelled. 2b is equal to 8. So b is 4. And once you know one value, you put there. So if I put b equals to 4 here or here, therefore a becomes what? 0. So these are the values. Very important question, can be asked in 4 marks, 5 marks, remember. Not difficult, you have realized. It's not difficult. Okay. So I think we end this session here. You try if you can do 29 to 32. Try if possible. Don't copy from anywhere. Otherwise, of course, I will cover in the next session. Right? But up to this, I hope you are clear. Okay, we stop now. We end the session now.